This section explains the DeepSeek model and code implementation. Let's first look at the DeepSeek model overview. The DeepSeek model integrates 3 advanced techniques in deep learning: mixture of experts, MOE, multi-head latent attention, and RMSNorm. The goal of DeepSeek is to combine these techniques into a single effective model capable of processing complex data efficiently. RMSNorm, root mean square normalization. RMSNorm is a variant of layer normalization that normalizes the input by using the root mean square of its elements instead of the mean and variance used in traditional layer norm. It has been shown to work effectively in certain types of models. Mathematical formula. Given an input tensor X with shape, batch size, sequence length, dimension, the RMS value for each sequence is calculated as follows. Xi are the elements of the input tensor along the sequence length. Epsilon is a small constant to prevent division by 0. Once the RMS value is computed, we normalize each element x by dividing by the RMS value and then scale it by a learnable parameter weight as follows, where the weight parameter is learned during training, allowing the model to control the scale of the normalization. Multi-head latent attention. Multi-head attention is a core mechanism in transformer models, allowing the model to focus on different parts of the input sequence simultaneously. Latent attention takes this further by using learnable latent queries to perform attention rather than computing queries directly from the input. For multi-head attention, we split the input into multiple heads and perform attention in parallel. The outputs from each head are then concatenated and projected back into the original dimension. Let's break down. 1. Multi-head attention involves projecting the input into multiple sets of queries, keys, and values, splitting them across heads. 2. Scaled dot product attention computes the attention weights for each head using the formula as follows, where H represents the individual attention head. 3. Final output is calculated, where AH is the attention output for head H, and WO is the output projection matrix. Mixture of experts, MOE. MOE is a model where the input is routed to a subset of experts based on a learned routing mechanism. This allows the model to conditionally activate different subsets of neurons depending on the input, leading to more efficient and scalable models. The routing probabilities are computed using a softmax over the logits produced by a linear layer as follows. WR is the weight matrix of the routing layer. The final output is a weighted sum of the outputs of all experts, where each expert's contribution is weighted by the routing probability as follows, where PI is the probability assigned to expert I. Now we implement the DeepSeek code. RMSNorm class. Multi-head latent attention class. Expert layer class. Mixture of experts class. DeepSeek block class. DeepSeek class. Testing the DeepSeek.